Have you ever stood on a beach, feeling a gentle breeze that's just strong enough to kick up a little sand around your feet? It's a familiar feeling. Now, imagine a world where the air is incredibly thick, much denser than our own, but the winds are almost ghostly quiet. We're talking about winds so slow, they'd barely rustle a flag. Yet, across these alien landscapes, we see massive dunes shifting and changing over time. How is this possible? Welcome to one of space exploration's most baffling puzzles, the low-gravity wind paradox. This mystery is most famous on Titan, Saturn's largest moon. Titan has an atmosphere that's 4 times denser than Earth's at the surface. Logically, you'd think that any wind in such a thick atmosphere would be incredibly powerful, like moving through water, but that's not what we've found. Data from probes like Huygens revealed that the surface winds on Titan are surprisingly weak, often blowing at just 1 or 2 miles per hour. That's barely a walking pace. It's a gentle, almost imperceptible puff of air. So here's the paradox. If the winds are that slow, how do they have enough force to move sand and dust? On Earth, you need a decent gust of wind to get sand particles airborne. On Titan, the particles are made of hydrocarbon sand, which is lighter than Earth's silicate sand, but the gravity is also much lower. Even with these factors, the wind speeds we've measured just don't seem strong enough to initiate that movement. They shouldn't be able to lift and carry particles to build the vast dune fields that stretch for hundreds of miles across Titan's surface. Scientists are scratching their heads. One theory suggests that maybe, just maybe, the winds aren't always this slow. Perhaps rare, powerful storms occasionally sweep across the moon, doing all the heavy lifting in short, violent bursts. Another idea is that perhaps the particles on Titan are stickier or have some electrical property that helps them clump together and then get moved more easily once a critical mass is reached. It's also possible that our models of how wind interacts with particles in such a different environment are simply incomplete. Solving this paradox isn't just a fun mental exercise. It helps us understand the fundamental physics that shape planetary surfaces across the universe. It's a reminder that even in a place with thick air, things don't always behave as we'd expect. What other cosmic puzzles are waiting for us out there? If you enjoyed this journey into a planetary mystery, please hit that like button and subscribe for more deep dives into the wonders of our universe. Thanks for watching.